Hello viewers, we are Aruna taking you through the story of O-Level Physics Paper 2. And this video, we're going to go through the marking guide for Senior 4 Physics 2 for the year 2022. So what is ticked on this side plan is what is available on this platform, and today we are going to go through the marking guide for Physics 2 for Uneb 2022 of Senior 4. Where necessary, the following constants may be used. So we shall start with question 1. Question 1 part A, Roman 1 says, state three fundamental quantities of measurements. And Roman 2, state the SI unit of any one of the quantities in A Roman 1 above. So let's start with part A. So one of the quantity we have mass, length, time, temperature, electric current, luminous flame, then amount of a substance. Then from and to they wanted the SI unit. So the SI unit for mass will be kilogram, for length will be meters, for time it will be seconds, temperature Kelvin, electric current ampere, luminous intensity candela, then amount of substance mole. And basically that's what they wanted in Roman in part A. So any three here is okay, and here any one is okay. So that was part A. Now we shall go to part B. Part B said, describe a simple laboratory experiment to determine the density of a small piece of stone. So small piece of stone is an irregular object. So how do we find density of an irregular object? Let's first make a sketch. So we shall have an overflow can filled with water to spout level. So this is level of water, it's at the spout level. Then you also have a beaker or measuring cylinder. To measure the volume of the water displaced. Then we shall have an irregular object, or the stone gently immersed in the liquid. So the mass m of that stone whose density is required is measured using a spring balance and recorded. An overflow can is then filled with water until it just flows out, is what it means, that point. A dry beaker is then placed exactly below the spout here. A piece of thread is tied round the stone and then lowered gently into the can until it is submerged. Some water is displaced by the stone and flows into the beaker. The volume V of the displaced water in the beaker is measured and recorded. The density rho of the stone is then calculated from mass over volume. So basically that is a simple laboratory experiment used to measure density of a stone. So now shall go to part C. Part C says a spring balance reads 120 grams when a metal block is suspended from it in air, and reads 100 grams when the metal block is completely immersed in water. Calculate Roman 1 the volume of the block and Roman 2 the density of the block. So volume of the block is equal to volume of water displaced, and that volume of water displaced will be got by mass of water displaced over density of water. So mass of water displaced is this excess, 120 minus 100, and density of water is 1, which gives you 20 centimeters cubed. Alternatively, you could say that volume of the block is equal to loss in mass over density of water. It will still give you the answer. Then Roman 2, the density of the block is mass over volume, mass volume, to give you that. That was part C. Then part D. A rectangular block of dimensions 4 by 6 by 9 centimeters has a mass of 9.6 kilograms. Find the maximum pressure it can exert on its support. Now here what you should realize, the dimensions here are in centimeters, but the SI unit is meters, so you have to convert these to meters. For mass it is okay because it is in kilograms. So maximum pressure will be equal to force, which is mass times acceleration due to gravity. Remember, from Newton's second law, F is equal to ma, so mass times acceleration due to gravity, and O, which is the weight. Then here the minimum area, you look for the smallest dimensions. So if you look at this, of these three dimensions, the smallest is 4 and 6. So those are the ones we use. And that's how you got the 4 Pascals. I think realize that here we converted this to meters. So don't forget to convert to meters. So here 1 mark was for this formula. Another 1 mark was for this conversion to meter, this half a mark for this conversion, and this one for the whole of the substitution. So like I told you, in UNEB, they usually give reports at the end of every marking session. So this year too, they made a report on what transpired during the marking process. So these reports contain 3 parts. They contain analysis, that is what the question required, weakness of candidates, and also advice where necessary. So this question required, the question required to state the fundamental quantities, the 3 fundamental quantities and their units, description of an experiment to determine density of a stone, solving a numerical question applying the relationship between mass, volume, and density, and numerical application of pressure. So it was a very popular question. Now the weakness is that failure to distinguish between fundamental and derived quantities. Some were giving volume and density, yet those are derived quantities. Then failure to describe an experiment appropriately. Appropriately means you describe the experiment in a logical order. You don't instruct the examiner that do this, do this. You have to tell us what you do. For example, if you are going to measure the stone, don't say measure the mass of the stone. No, you have to say that the mass of the stone is measured and recorded. So Experiments they don't instruct the one going to mark your paper. Then failure to apply the formula for density to solve numerical problems. And solving a numerical problem involving pressure was a challenge. And the biggest challenge was converting. So some students took the centimeters as the SI unit, but centimeters is not an SI unit for length. The SI unit is meter. Then advice to teachers, teachers should encourage students to carry out experiments always so they can know the logical flow. Then give enough numerical problems that require application of physics concepts. That was question 1. Now we shall go to question 2. Part A says, what is meant by conduction of heat? So conduction of heat is the process of heat transfer through matter from regions of high temperature to those of low temperature without, know this word, without movement of matter as a whole. Most students forget this last statement, but we really need it in the definition. Then part B says describe ways the fixed points of a thermometric scale can be determined. So fixed points, we have two. We have the lower fixed point and the upper fixed point. Now here they didn't specify whether the upper or lower. So what you needed to do was to get both. So let's start with the lower fixed point. So you'll have our clamp here, then our funnel, then this one to collect the water, then here we shall put lumps of ice. So you come and put lumps of ice in the funnel. Then you shall need a thermometer to measure the lower fixed point. Then the melting ice will be collected in the beaker. So basically that is a setup. So just start and say that the bulb of the thermometer is placed in pure melting ice. That is the bulb. Then a beaker is put below the funnel to trap melting ice. Time is allowed for the mercury thread to reach a steady level for the reading of the thermometer to be stable. So this level is marked and is the lower fixed point. So you have now got the lower fixed point, but remember we need the upper fixed point. Now before we go there, let's first see the marker location for this slide. Okay, now let's go and get also the upper fixed point. For the upper fixed point, you shall need also another diagram. So this will be the heat to heat this liquid, and when it boils, this will be now the steam. So you also need the thermometer to measure that, to get that reading. And this will be the escape route for the steam. So we shall start and say that the bulb of the thermometer is placed in steam from boiling water at standard atmospheric pressure. Now this word has to be seen, standard atmospheric pressure. Then time is allowed for the material thread to rise to a steady level. This level is marked and is the upper fixed point, as simple as that. So this experiment has to be as brief as possible. Don't try too much. Then part C says the ice and steam points on an ungraduated thermometer are found to be 194 millimeters apart. What temperature is recorded in degrees Celsius when the length of the material thread is 68 millimeters above the ice point mark? So this will be L100 and L0 and L00. Then this will be L theta. So I shall come and say that first of all there is a formula which connects the length so this will be L theta minus L naught, and this will be L100 minus L naught. So this x is the 68 and this is the 194 times 100 degrees Celsius to give you 35 degrees Celsius. And that's what they wanted. Then part D says briefly explain the meaning of greenhouse effect. So you start by saying that radiation from the sun of short wavelength penetrate the atmosphere. Okay, the radiation are absorbed by the Earth's surface and other objects become warm. The Earth and the objects then radiate energy of long wavelength, which are absorbed by greenhouse gases in the atmosphere. The warm atmosphere radiates back to the Earth, raising its temperature. So this effect is what we call the greenhouse effect, abnormal increase in temperature. Alternatively, you could explain greenhouse as that when radiations from the sun of short, so this word short wavelength is needed, you can't avoid it, fall on glass, the radiations are absorbed by plants and soil inside the house, which become warm. The warm objects inside radiate energy of long wavelength, low energy and penetrating power, which cannot penetrate glass but remains inside the house. And that's what they wanted. Then part E, explain the fact that a dull surface feels hotter when a shiny surface feels hotter than a shiny surface when both are in the same environment. So what we need to remember is that dull surfaces absorb most of the heat energy that fall on it, while shiny surfaces reflect most of energy falling on it. So what does that mean? It means that when touched, the body extracts more heat from the dull surface than from the shiny one. Thus, a dull surface feels hotter. And that's what they wanted. So still question analysis. The question required definition of conduction and how to determine fixed points of a thermometric scale. Solve numerical problems involving application of fixed points. Explain the meaning of greenhouse effect and explain why dull surfaces feel warmer. than shiny surfaces in the same environment. So the weakness is that failure to give clear definition of conduction. Like I told you, there's the last part, most students forget it. Then students lack knowledge about the determination of fixed points. Students also lack knowledge to use in explaining greenhouse effect. Those things of long wavelength, short wavelength, penetrating power, energy, they are not seen in the explanation. Then failure to explain why dull surfaces feel hotter than shiny surface. And advice is that teachers should emphasize the correct and accurate descriptions of concepts in thermal properties of matter. So this question was about thermal properties, and use hands-on and minds-on approaches while teaching. Get students involved in the teaching process. So that was question 2. Now we shall go to question 3. Roman 1 says, state the principle of linear propagation of light. So the principle of linear propagation of light states that light travels in a straight line, as simple as that. Then Roman 2 says, an opaque object is placed between an extended source of light and a screen. Sketch a labeled diagram to show regions of the shadow formed when the screen is very far from the object. So extended source means the source of light is wide. We have extended and point. Then you have the opaque object and the screen. So those rays will reach the screen and to form what we call penumbra. However, the ones passing through that point do not reach the screen because they stayed very far from the screen, and that would be the umbra. And that's what they wanted. They wanted those two types of shadows. Then Roman 3, state any two properties of images formed by plane mirrors. So 1 is that they are virtual, and 2, they are laterally inverted. 3, the image is the same size as the object, and the image distance from the mirror is equal to the object distance from the mirror. That was part Roman 3. Now we shall go to part B. Part B says, describe the method of determining the focal length of a thin convex lens using a distant object. So we shall need a diagram here. So we shall have a screen, then the lens, lens holder, and the meter rule to measure the distance. So a convex lens is fixed on a lens holder and then placed in front of the screen. Okay. The position of the screen is adjusted until a focused image of a distant object is formed on it. Know this word, focused image and distant object. The distance small f between the lens and the screen is measured and recorded. And this is equal to the value of the focal length of the lens, as simple as that. So that is what they wanted. Then part C, they said, Roman 1, what is critical angle as applied to light? And Roman 2, state the conditions for total internal reflection to occur. So Roman 1, critical angle is the angle of incidence in the denser medium, for which the angle of refraction in the adjoining less dense medium is 90. All those keywords are needed. Then the conditions for total internal reflection to occur: 1. Light must be traveling from an optically denser medium to an optically less dense medium. And 2. The angle of incidence in the optically denser medium must be greater than the critical angle. And that's what they wanted in that part. Then part D, Roman 1, a monochromatic light is incident at the air glass boundary as shown in figure. If the refractive index of glass is 1.5, find the value of angle I. So you realize that here it's true they gave the angle of incidence, but here they didn't give the angle of refraction. This is called glancing angle. So your work is to look for getting this angle by saying 90 minus 51. Otherwise, if you didn't do that, then the answer couldn't come out. So let's go and get the value of I. Then Roman 2, they said, state 2 reasons why convex mirrors are used as driving mirrors. So for Roman 1, first of all, is to get the angle of refraction. Then you remember Snell's law at the boundary. So n sine I is equal to sine R, because this is air and refractive index of air is 1. Then substitute for n, then for R, and remain with I as the only unknown. So using a calculator, I will be 24.8. Then Roman 2, why convex mirrors are used as driving mirrors. 1 is that they have a wide field of view, and 2, they produce upright images. And that's what they wanted. So question analysis, this was the requirement. 1, knowledge of electrolinear propagation of light, ability to sketch a diagram showing formation of an extended object which is very far, knowledge of properties of images in plane mirrors, ability to describe an experiment to determine the focal length of convex lens using a distant object, knowledge of total internal reflection, and application of reversibility of light in solving numerical problems. So here for me what I used was Snell's law. So you can use this or Snell's law. Then the weakness 1 is failure to consider the object being very far with umbra not touching the screen. So the keyword was the word very far. Then failure to distinguish between real and virtual images. Lack of knowledge about reasons why convex mirrors are used as driving mirrors. Then lack of knowledge about application of Snell's law in solving numerical problems. So advise that teachers should emphasize construction of red diagrams and the nature of the image formed. Then more numerical calculations involving Snell's law should be done. Carry out experiments, stroke demonstrations with learners. Question 4, part A says, define the following as applied to wave motion. Roman 1, nodes, Roman 2, antinodes. So for nodes, nodes are points of zero amplitude on a standing wave, as simple as that. So the keyword is zero amplitude. Whereas antinodes are points of maximum amplitude on a standing wave, as brief as that. Then part B, what are progressive waves? So progressive waves are waves that move from the source to another region while transferring energy. That's what they wanted. Then part C, a tuning fork making 100 vibrations in 2 seconds produces sound which travels at 320 meters per second through air. Find Roman 1, the frequency of the sound, and Roman 2, the wavelength of the sound. So frequency will be number of vibrations over time, which is 200 in 2 seconds to give you the frequency as hertz. Then Roman 2, we know that V is equal to Fy, F lambda, where V is velocity, frequency, wavelength. So substitute for velocity and frequency, then get wavelength. And that was part C. Part D, figure 2 shows a pattern of straight water waves moving in direction AB, incident to a barrier CD. Copy the diagram and show the pattern for the wave after hitting the barrier. So we shall come and first copy the diagram. Then shall show the direction of the wave. So there they are reflected to pass through the principal focus. Therefore, our waves will also follow the same path, converge towards the principal focus, and then thereafter diverge. And that's what they wanted. Then for part E, they said Roman 1, state the condition for resonance to occur. I think let's first write that. So the condition is that the forcing frequency must be equal to the natural frequency of the body. Alternatively, you can say there must be a regular external source of energy. That was Roman 1. Then Roman 2, with the aid of a labeled diagram, describe an experiment to demonstrate resonance due to sound waves. So we need a diagram as they told us. So we shall come and draw a burette with a tap, then we fill it with the liquid, and then put a tuning fork at its mouth. And then put a beaker to collect the water which is flowing when you open the tap. So you shall come and say, 1, a vibrating tuning fork is placed near the mouth of the tube, which is here. 2, the tap is opened to allow water to flow. So the tap is opened, and as the water flows, the level keeps on reducing. A loud sound is heard. Note this word, a loud sound is heard at some point, and this is due to resonance. And that's what they wanted. Then Roman 3, state one application of resonance. So resonance is applied in, you can say, measurement of speed of sound in air. You can also say determination of frequency of AC source. You can also say tuning musical instruments, tuning radios, and also driving springboards. And that's what they wanted. So question analysis, it required knowledge of nodes, antinodes, and standing waves, knowledge of frequency, wavelength, and the use of the formula. There is also required ability to describe an experiment to demonstrate resonance of sound waves. The weakness is failure to apply the knowledge of this formula. Then to failure to draw the refracted wave pattern correctly. Remember, the mark is on the pattern and the shape, and pattern and the direction. Then failure to interpret how to demonstrate resonance correctly. The diagram had to be drawn. Lacked knowledge about conditions necessary for resonance to occur. So advice is that teachers should demonstrate properties of waves using ripple tank. Then practically demonstrate resonance due to sound waves. So now we shall go to question 5. Part A says define the following. Roman 1, adhesion, and Roman 2, cohesion. So one, adhesion is the force of attraction between molecules of different substances, while cohesion is still force of attraction, but this time around it is between four molecules of the same substance. That's the difference between the two. Adhesion, different substances. Cohesion, same substances. Then part B, state the factors that affect surface tension. So 1, change in temperature, and 2, degree of purity of a liquid. Mechanical disturbance of the liquid, like shaking. And that's what they wanted. Then part C, Roman 1, with the aid of a diagram, describe an experiment to demonstrate how a siphon works. Then Roman 2, give one use of a siphon in everyday life. So here we shall need a diagram. We have a stand, we have a trough, then we have a jet tube, then we have liquid in the trough, so we shall come and say that the setup is as shown above. The jet tube is filled with a liquid by sucking at end B. On releasing, the liquid runs out through the tube continuously. And that's what we want. Then uses of siphon in daily life. 1, they are used in emptying petrol from drums. 2, they are used in removing water from fish aquariums. 3, they are used in operation of water closet like flush toilets. And that's what they wanted. Then part D, explain what happens to atmospheric pressure as one goes higher and higher from the ground. So one, we know that atmospheric pressure onto the Earth's surface is due to the total weight or the density of air on it. Therefore, as one goes higher, the quantity or the density of air decreases. This therefore decreases the atmospheric pressure. And basically that's what they wanted. Then for part E, the smaller piston of a hydraulic jack has an area of 0.2 square meter. A force of 20 Newton is applied on the smaller piston to raise a car resting on the large piston of area 2 square meter. Find the force that raises the car. So know that small area is this and small force is this. Therefore, big area is this and big force we do not it. But the good thing, we know that the ratio is the same. So ratio of big force over small force is equal to big area over small area. Then substitute for small force and small area and big area. Then make F2 the subject. So that will be the force. And that's what they wanted. Question analysis. The question required knowledge of adhesion, cohesion, and surface tension. Then it also required ability to describe how a siphon works and give its application. Explain the variation of atmospheric pressure with height and apply the concept of transmission of pressure in liquids. So the weakness is inability to describe how a siphon works. Then lack of knowledge on how and why atmospheric pressure varies with height, and inability to solve numerical problems on pressure. So advice to teachers should demonstrate how a siphon works, practically handle concepts relating transmission of pressure in fluids, and give numerical problems related to pressure. Then question 6 part A says describe the structure of an atom. So this question was on modern physics. So one, we know that an atom consists of 3 particles, that is protons, neutrons, and electrons. The protons and neutrons are located in the nucleus, while the electrons are located in the orbits that surround the shell. And that's what they wanted. That's the structure, what it contains and where they are located. Then part B, what are radioisotopes? So radioisotopes are atoms of the same element with the same atomic number but different mass number that are radioactive. So this word is needed. Why? Because if you just stop here, it means they are isotopes, but they said radioisotopes. Then part C, a nuclide P of mass number 214 and atomic number 82 decays to nuclide 2 with the emission of 2 alpha particles and a beta particle. Roman 1, write a nuclear equation for the decay process. And Roman 2, determine the mass number and atomic number of 2. So it decays by emission. This is now the new nuclide 2. We don't know the mass number and the atomic number yet. But know that the decay was followed by emission of 2 alpha particles and 1 beta particle. Therefore, equilibrium, it means that the mass number before and after are the same. So mass number before, then after we have x, then 2 times 4, then 0, which gives you x as 206. Then atomic number, we have this 82 before, then you have y, 2 times 2, and -1 to give you y as 79. And that's what they wanted. So that's how marks will be awarded. Then part D, part D Roman 1, what is half-life of a radioactive material? Then Roman 2, the half-life of a radioactive element is 2 hours. If the initial mass of the element is 48 grams, find the mass that decays after 8 hours. So first they wanted the definition for half-life. So half-life of a radioactive material is the time taken for a half of the nuclei of the radioactive substance to decay. Then the calculation, we know that half-life was given as 2 hours, initial mass was 48, and total time was 8 hours. Therefore, the number of half-lives will be total time over the half-life to give you 4 half-lives. Meaning, first it will be 48 divided by 2 to give you 24, that is 1 half-life. 24 divided by 2 to give you 12, that is second half-life. 12 divided by 2 to give you 6, that is third. And 6 divided by 2 to give you 3, which is fourth. So this is now the mass present. Therefore, the mass that decays will be initial minus present to give you 45 grams. Alternatively, you can use the formula that Nt over No, where Nt is the mass present at the time t, over No, which is mass initially present, is equal to a half raised to the power now t over t a half. And think we realize t over t a half is this value of n. So come and substitute for n naught, then t, and t a half. So it's only Nt which is unknown, so I'll look forward to making it the subject. Then I can get the mass that decays. And that's what they wanted. Then part E, state 2 industrial applications of radioactivity. So yeah, one you can say they are used in detection or location of leakages in underground pipelines carrying fluids like water, oil, sewage. Then 2, they are used in monitoring, stroke checking the thickness of paper during production. Used to detect flaws in metal sheets during metal casting. Used in determining the rate of wear and tear on piston rings in industries. Used in hardening of rubber, stroke paraffin. Used in thickening of lubricant oils. Used as a source of energy. Used in food preservation by sterilization. So any 3 would be okay. Then part F, Roman 1, what is nuclear fission? And Roman 2, state the conditions necessary for nuclear fission reaction to take place. And Roman 3, state the condition for nuclear fusion. Know this word, here it was fission, now it is fusion. So one, nuclear fission is the splitting of heavy unstable nucleus to form two lighter nuclei accompanied by release of energy. Then Roman 2 conditions, we have heavy nuclide and low temperature. Then Roman 3, there must be two fairly light and unstable nuclide. 2 high temperature is required. So question analysis, the question required knowledge about structure of an atom, definition of radioactive isotopes, ability to write nuclear equations, knowledge of half-life, industrial application of radioactivity. Weakness was failure to interpret definition of an atom. Then 2, confused isotopes instead of radioisotopes. That's why I told you that you must end with that word, radioactive. Lacked knowledge in calculating mass decay. Then confused mixed industrial application with medical application. So the question was specific, they want industrial. Then advise, guide learners on correct interpretation of questions. Teach learners on how to write balanced nuclear equations. And give enough numerical method examples to determine half-life and mass number of atoms. That was question 6. Now we shall go to question 7. Question 7 part A, Roman 1 says, what is meant by electrical resistance? Now this was under electricity. And Roman 2, derive an expression for the effective resistance of two resistors connected in parallel. So the first one was the definition. So electrical resistance is the opposition to flow of current through a component in a circuit. Then derivation, we shall need a diagram having two resistors in parallel connected to a dry cell or a voltage supply. So in that case, current flows from the source to the junction A, then it splits into two, I1 and I2, then it again combines at junction B and goes back to the source. So if R is the effective resistance of the system, then from Ohm's law, I, which is total current, is equal to V, which is total voltage, over R. But when it comes to I1, it will be V over R1, and I2 will be V over R2. Then remember that total current to I was got by adding the two currents. So when I substitute for I1, and I2, I come up with that. Then I realize that V is the same throughout. So I can cancel to get that. So I've managed to get a relationship between R1, R2, and R. And that's what they wanted. Then part B says, resistors of resistances 3 ohm and 9 ohm are connected to across a battery of AMF 10 volt and internal resistance. Know this word. Now here they are giving you internal resistance. Sometimes they say internal resistance is negligible. Calculate Roman 1, the total resistance in the circuit, and Roman 2, the power dissipated in the 3 ohm resistor. So these two resistors are in parallel. So I'll come and combine the two resistors in parallel. Then I can get the total resistance because there was an internal resistor. That was Roman 1. Roman 2, the power, so I'll come and say EMF is equal to I in brackets capital R plus small r. So come and substitute. Remember, this was the same as this, which is 5. That's why I put here 5. Therefore, I will be 2 ampere. And PD across the parallel combination will be IR, which is IR to give you that. Therefore, power dissipated in a 3 ohm resistor is V squared over R1. So V squared R1 to give you 6.75 watts. And that's what they wanted. Then part C. So C Roman 1 says, what is the major cause of electrical power losses along the transmission line? And Roman 2 says, explain how the power losses can be minimized. So power loss due to resistance in the transmitting wires. So the resistance in the transmitting wires causes the power loss. Then 2, how they can be minimized. 1, reduced by lowering the current when the PD is stepped up. And basically that is it. Alternatively, you can say by using thick wires of low resistance. And that's what they wanted. Then part D, Roman 1, draw and label the structure of a dry cell. And Roman 2, briefly explain how to charge a lead acid accumulator. So here we shall only need the essential parts of a dry cell. So the first one is the casing, which acts as the cathode. Then we need that liquid, which is ammonium chloride jelly. Then we shall also need that, which is powdered manganese dioxide and carbon. Then we shall also need that, which is carbon rod and acts as the anode. And lastly, we shall need the brass cap. Roman 2, how to charge a lead acid accumulator. 1, you can set by passing DC of a suitable value in opposition to the EMF of the accumulator. Alternatively, you can say connect the DC of greater EMF than that of the accumulator. The positive of the supply is connected to the positive of the battery, and the negative of the supply is connected to the negative of the battery. And that's what they wanted. So question analysis, the question required knowledge of electrical resistance, derivation of effective resistance, application of Ohm's law, and knowledge of power loss in transmission lines and how they are minimized. Weakness was failure to derive the equation for effective resistance, inability to apply Ohm's law in solving circuit problems, and lack of knowledge on cause of power loss in transmission line and how they can be minimized. Advice is teachers should emphasize on how to derive some formulae of resistance and give many numerical examples on application of Ohm's law in solving numerical questions. Now shall go to question 8. Question 8 says, part A, Roman 1. Differentiate between ferromagnetic and non-ferromagnetic materials. Then state 2 examples of each of the material in A Roman 1 above. So ferromagnetic materials are strongly attracted by a magnet, while non-ferromagnetic materials are weakly attracted by a magnet. That is one difference. Another one could say the dipoles in the domains of the ferromagnetic materials are aligned in one direction, while those in each domain of a non-ferromagnetic material are randomly aligned. Then the wanted examples in each. So for ferromagnetic materials, we could give iron, steel, nickel, cobalt. Then for non-ferromagnetic materials, we could give glass, copper, wood, brass, fur. Then part B, sketch the magnetic field pattern of the following. 1. A bar magnet. 2. Bar magnet in the Earth's field, this is field, with its south pole facing the north, Earth's north. So you get a bar magnet with both north and south poles. Then we show the pattern and the direction. Another field line, up and down, another one up and down. And that's what they wanted. From and to, we have south placed facing the geographical north, then you can get the fields. So as it goes, it begins to be interfered by the Earth's field and the shape changes. But far from the magnet, there is less effect, so it becomes straight. I think you see this last one is straight, unlike these ones before. Meaning the ones which are straight are far from the magnet. So this is what we call the neutral points, this and that. And basically that's what they wanted. Then part C, Roman 1, state 3 factors which affect the magnitude of the force on a current carrying conductor in a magnetic field. I think let's start with that. So 1 is the magnitude of current in the conductor, length of the conductor in the field, strength of the magnetic field. Then the angle between the magnetic field and the conductor. So now shall go to part C, Roman 2. Roman 2 says, describe with the aid of a diagram how the step-down transformer works. So the keyword is this word step down. So we're coming and draw our laminated iron core. Now step down means the number of turns in the primary side are more than the number of turns in the secondary side. Also, the winding of those turns matters. I think I want you to see this. It is like this. It goes like this. It is different from the secondary side, as we're going to see. Do you notice a difference in the windings? They are somehow different. Because this one, if you look from up, the winding is like this. If you look from here, the winding is like this. So the setup is as shown above. The number of turns in the primary coil is more than the number of turns in the secondary coil. That is the note what you should always remember. So when an alternating voltage Vp is applied to the primary coil, it sets up an alternating magnetic flux in the soft iron core which links the secondary coil. And as a result, an alternating EMF Vs of small value is induced in the secondary coil. That's what they wanted. Then Roman 3, a transformer has 200 turns on the primary coil and 1000 turns on the secondary coil. If a voltage of 1600 volts is fed in the primary, calculate the voltage on the secondary. So we know that the number of turns is proportional to the PD. Therefore, Vs over Vp is equal to Ns over Np. Then you can substitute for Vp, Ns, Np, and look for making Vs the subject. And that's what they wanted. Then Roman 4, state any two causes of energy losses in a transformer. One could be resistance of the windings. Another one could be loss due to eddy currents. Another one could be hysteresis loss. And the other one could be poor flux linkage. Then question analysis. The question required knowledge of the difference between ferromagnetic and non-ferromagnetic material and examples. Then ability to sketch magnetic field patterns. Then also state the factors that affect magnitude of a force on a conductor, current. Describe how a step-down transformer works and solve numerical problems. So the weakness, candidates lack knowledge on the difference between the two, ferromagnetic and non-ferromagnetic. Also some of them failed to draw magnetic fields of the bar placed in the Earth's field. Lack of knowledge about factors affecting force on a current carrying conductor. Then confused between step-down and step-up transformers. And inability to solve numerical problems on transformers. A device should demonstrate magnetic fields of bar magnets and current carrying conductors. Describe how a transformer works and give many examples on solving numerical problems. Then explain the cause of energy / power loss in a transformer and how they can be minimized. Advise learners to use recommended textbooks by NCDC non-pamphlets. Emphasis on applications of physics concepts. So general observation is that most candidates showed inadequate knowledge in answering questions that demanded for explanation. Now, physics, you cannot run away from those explanations. And as we explain physics concepts. So you should write physics. Then questions that involved higher order thinking skills, like descriptions on application of physics concepts, is still a challenge to many candidates. So I encourage you to adequately prepare for this UNEB so that you don't do the same mistakes which were done by those in the previous year. Otherwise, that brings us to the end of this video. Thank you for watching, and bear in mind that the next video will now be for A level, and that will be Senior 6 Math 1 for Uneb of Uneb 2022. So if you have not yet subscribed, please click on the subscribe button below this video. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.